Greetings and hello, this is Miss Jackson. I'm going to make the second video in the Module 3 test review. This video is going to most likely be fairly long, I would posit and suggest, because it has three big chunky word problems in it. And word problems can go a whole lot of places and take a whole lot of time to get through. So I'm going to kind of try to break these down. I will say there will be a healthy number of word problems on the upcoming test, not just word problems where you're solving to find a specific answer, but word problems where you're looking for relationships or patterns, word problems where you're looking at models and ways to solve it, what could and could you not use, things like that. If I assume you're watching this in the year of 2024, but if you're watching this in a later year, this may not apply to you so much. If you're watching it after I make it for this school year, though, I am going to, we are in third grade going to wrap up this unit truly on Monday, and we're giving ourselves, I think, 3 days of word problems just to focus on those word problems leading into this test, where we will look at solving word problems, look at creating models, look at creating equations. And we've already been doing that in class, but I really wanted to have almost like a little mini word problem boot camp leading into this test, because the word problems are about to just get bigger and bigger for us. So here is the first one. It says, Greg had some sunflower seeds. Now note, we don't know how many sunflower seeds, we just know he had some sunflower seeds. He stored them in an egg carton that is divided into 12 sections. Greg placed 7 sunflower seeds in each section of the egg carton. This equation, the one that they have listed for us, can be used to find the number of sunflower seeds Greg had. And if you're looking in the middle of the screen, it is the unknown box divided by something equals 7. How many sunflower seeds did Greg have? This is a great place to use that strikeout tool on the test. And if you're just using a paper copy, it's a great place to just use your pencil to mark out things that you know cannot be the right answer. So take a minute and just look at this equation and maybe pause this and think about all the things we've learned. Which option or options do you know absolutely cannot be the correct answer that you could get rid of from the start? And on a computer, the strikeout tool looks like this. And you would click that and then click the ones you want to get rid of, and it marks them out for you. Well, I'm looking at this problem, and it's a division problem. And the one thing that we have hammered home all year is that, at least in third grade, in a division problem, the first number is our total, and it is the biggest number in the problem. So when I'm looking at the answer choices, I can absolutely get rid of option A, because that's a 7. You can't put a 7 in that box because 7 is smaller than 12. I'm also looking at option C. And while C, the answer is 12, 12 is the same size as the second number, 12 divided by 12. While that is a proper division problem, 12 divided by 12 is 1. And when I look at this answer here, the answer is not 1. Therefore, that front number cannot be 12. Just by taking a moment and reasoning through my answer choices, we've now reduced our choices down to 2. It's a 50-50 chance at this place. So if you look at this and start floundering like a fish on land, you don't have a clue what to do, at least you have a 50-50 chance now of getting it correct. But let's look at what we're going to do to make sure we get it correct. There are several strategies that you can use to solve this problem, and we have talked about them in class repeatedly. You're going to have the strategy that works best for you. I'm going to show a few here. If I don't show your strategy, but you can do your strategy and it works, that's fine. So one thing we've talked about is taking our division problem and using the inverse operation, which is multiplication, to solve for a missing part. To solve a division problem using multiplication, we just flip this backwards. So we could do 7 times 12 equals something. Now, unfortunately, we haven't learned how to multiply two-digit by one-digit numbers using like the standard algorithm or something that we're traditionally used to, but we do know how to solve it by decomposing. We've done that plenty of times. We can decompose 12 into 10 and into 2. At this point, we need to multiply our 7 by both factors. 7 times 10 is 70. 7 times 2 is 14. If we add 70 and 14 together, we come up with 84. And look right there, there's an answer, 84 for us. If you're not comfortable with that strategy, and some kids just aren't, that doesn't quite work for them, make a math model. Make a strip diagram. Go back and reread what it tells us. Greg had some sunflowers, and we already said we don't know how many. He stored them in an egg carton that is divided into 12 sections. No, that's probably 12 sections. Let's number them. 6, 7, 8, 9, 10, 11. There you go, 12 sections. He placed 7 sunflower seeds in each section. And I always encourage the students to draw a model. It is like pulling teeth to get them to do it. I'm not sure. I think it's just something they're not completely used to doing. But when you draw a model, I compare it to juggling. When you're juggling, if you're trying to juggle 10 things at one time, it's extremely difficult, far more difficult than juggling, say, 2 or 3 things. Well, that's what's happening when we work these word problems in our brain. When we take this information and we set it down on the paper with a model, a visual model, it's like setting down some of the objects that we're cognitively juggling. And it's going to keep us from making as many mistakes typically. Or sometimes it kind of lights the path of what we need to do to solve this. So here we don't know the total, but we can look at this and say, oh, we've seen this before. I know I need to combine all these sevens. It may be a lot of work, and it may be a lot of work. We could count by sevens here and go all the way through until we end up at our total of 84. Now, if you're doing that, you have to count very, very carefully to make sure you've not made a mistake. And I would maybe double or triple check my counting. Certainly, if you get an answer that's not an option, an answer choice, I would suggest you've made a mistake. Go back and double check. So at this point, our answer is 84. That's just a couple of ways to solve this problem. Other kids have other strategies. Some kids are going to look at this and they're going to do 12 times 7 and they're going to add 12 together 7 times, and they really like to put it down on paper because it works for them and it keeps them from getting confused. There's 6 12s, add another 12 here, start combining all this together, and then you'll eventually get to your answer of 84. That's fine too. Wherever you're at in this progression of learning how to divide and multiply is fine. Just make sure you show some work. Okay. Problem 4. And we're really going to start hitting these on Friday the 5th, and we'll continue looking at these throughout the next week leading up to this test. Oh, I'm going to erase that. I wish that wasn't there. Here we go. Okay. Rose put 345 grams of sand and 368 grams of silt in a container. Then her teacher put in some clay. In all, the soil mix weighs 984 grams. Which equation can be used to find the amount of clay in the soil mix? Here's another time that if you will make a model, it helps you to stop juggling so many items in your brain. The model that I most like to use for this is a strip diagram for addition and subtraction. If you recall, our strip diagram up here for multiplication and division is usually a long, skinny rectangle with a bunch of sections that are equally sized with, and all of them have the same value. Well, addition and subtraction is a little bit different. So what we're going to see is usually there are 2 parts. The top part represents the total, and the bottom section represents all of the parts that come together to make that total. So let's look back at what we know. We know that she put 345 grams of sand in a container, 368 grams of silt, and then her teacher put some clay, but we don't know how much clay, so there are our parts. In all, the soil mix weighs 984 grams, so we have our total. Now we're trying to find the equation that we could use to find the amount of clay in the soil mix. This is a part whole model, the strip diagram, and in this case there are more than two parts, so we'll call it a part whole model. And kids have been working with part whole model since first grade, and this works the same way. We're just now dealing with bigger numbers. So with our total here, to find the missing part, what we could, there are a lot of things we could do, but one thing we could do for sure is subtract the parts from the total, and that will give us that missing clay part. At no time should we add a part to the total. If you come across a problem where you're adding a part to the total, that's not correct. So let's look at A. Here's the total, but I'm looking at this next operation, and it's adding that silt part to it. Well, that's going to change our number in a way that brings us up over what the total even started as. You can't have more than the whole, more than the total. So A is not going to be correct. Let's look at B. It starts with the total again, and here it subtracts that sand part, and then it subtracts the silt part, and that would leave me with the missing clay part. So this is a good equation here that could work for us. For C, we have the total, and then if you look at the operation carefully, we're adding the parts to it. Just roughly adding that, you're going to be at somewhere around 1,500 or 1,600. We'll say 1,600. Let's round up here for the value of the clay section. Well, that's not even a reasonable answer. This is when that "is this a reasonable answer" part comes into our lives. Can the clay be 1,600 if the total is only 984? No, that's not reasonable at all. Lastly, I see the total. We're subtracting one part, but then we're adding the other part. That is not going to work. So our answer choice here is going to be B. I would like to take a quick minute and show you another way that this could be represented. And even though they didn't do it here, because we've been learning about parentheses, I would like to add in a little option E just to look at it. Another way that option B could be represented that really means kind of the same thing as B would be your total minus the two parts added together. And it's something that kids tend to naturally do, especially when we get into these addition strip diagrams. They automatically want to add these two parts together, or however many parts they have, come up with whatever that number is, and then subtract it from the total. And that would be a way to find the answer. So if you ever see an option like this, those parentheses kind of change everything for us. Because remember, those parentheses mean do that first. Well, if you added these two parts together and then subtract that from the total, you would get that missing part. That's just another kind of perspective or way to look at that. Okay, let's look at 5. Joseph set a goal to practice piano for a certain number of minutes this week. He has already practiced for 450 minutes this week. He has 180 minutes left to practice in order to meet his goal. Let's go ahead and just set up really quickly a strip diagram for this, because that's going to help kind of get this information put down on paper for us. So we're going to start out with that addition and subtraction strip diagram, and in the top is our total. The total is going to be the number of minutes he wants to practice. Well, we don't know what it is. It just said a certain number of minutes, so we're going to have to represent that with a question mark. Our parts are going to be what he's already practiced and what he still needs to practice. He's already practiced 450 minutes. He has 180 minutes left to practice in order to meet his goal. Which equation could not be used to find the number of minutes Joseph set for his goal? So which equation cannot be used to find the total? All right, I'm looking at option A. It says 180 plus something equals 450. 450 here, it's telling me that that would be his goal, what he's trying to get to. But he's not trying to get to 450 because he's already practiced 450 and he's going to practice 180 more. So this top number can't be 450. So that's not a way to find what he still needs to practice. B, something minus 450 equals 180. Well, that is true because that something would be our total. The total minus one part should give you the other part. So that would be a way to find it. C, this is adding our parts together. 450 plus 180 equals something. Well, that's true. That's what we do with these parts down here on this addition and subtraction strip diagram. We add all the parts together and it should give us the total. So that would be a good way to find it. And then D, something minus 180 equals 450. This is kind of like B, but in reverse. Something, our total, minus one part should give us the other part. So that would be a good way to find the answer. The only one of these that would not give us the answer would be A. When you look at 5, another thing that you could do, because they do give us all the parts, there's not a missing part or anything like that. You could go ahead and add your 450 plus 180. And find your total and fill that in, 630. And if we looked at A, we would not add 180 to 630 and be able to get 450. Now we could take 630, subtract 450 and get 180. We could add 450 and 180, which we've done, and get 630. Or we could take our total 630, subtract 180, and end up with 450. Okay, we're going to stop here on this video because that's a lot. Word problems are a lot, and there are just so many places in third grade that they could end up going. So let's stop that there. I'm going to try also to send home maybe another page of word problems at the beginning of the week if I can find some sort of resource to send home.